All right. So I did a little bit of a different spin on this presentation. We're going secret special agent themed. So, hello, everybody. My name, again, is Kiah Imani, and today you'll learn how to tackle some of the most challenging AWS workflows entirely from your laptop, like a true secret agent. And don't worry, no self destructing laptops involved. All right, this is your mission briefing. First, we'll talk about why building on AWS feels like trying to defuse a bomb. Then I'll show you the toolkit, LocalStack, that makes it possible to run the cloud locally. We'll go through some real tactics you can use today and highlight a cloud developer success story. And we'll wrap up with a debrief and your questions. Hope that sounds good. Your mission, should you choose to accept it, is to build and debug cloud-native AWS workflows without waiting on deploys, without a build attached, and without relying on shared dev environments that never quite match production. You'll learn how to operate under the radar and catch bugs before they escape into the wild, production being the wild. Okay, so let's walk through a real world example in this sample app. So here we have an image resizer app, and how it works is simple. Someone uploads an image, a Lambda function automatically resizes it. The resized image lands in a second S3 bucket. Super simple, super common, and also very annoying when it comes to debugging time when something goes wrong. And in the field, one thing that you can guarantee is that something will go wrong. You wait on deploys just to see an IAM permission error. You trigger an event and nothing happens. You hit a bug you can't reproduce. And that feedback loop, painfully slow. Every mistake costs time, money, and morale. Uploading a file might not trigger the Lambda. What happens then? Permissions might silently block it, the worst kind of error, silent ones. And the resized image may never appear, and then you're stuck guessing why, or worse, redeploying to find out. And then if you're testing this in real AWS, you just paid $3.42 to confirm that your bug still exists. So that's where your toolkit comes in. LocalStack is your portable AWS cloud. It runs dozens of AWS services entirely on your laptop. Services that are depicted here are nowhere near an exhaustive list. No internet connection required, no AWS account needed, no surprise bill at the end of the month. So, why simulate this mission locally? Well, I'm glad you asked. You move faster, you experiment safely, you reproduce bugs easily, and you save money. And you're no longer at the mercy of CI/CD pipelines or shared staging environments. Instead, you are in control. All right, so let's go through some tactics. Let's kick off the first one. That's running your workflow end-to-end locally. And this is what most of us wish we could do before committing or pushing anything. Here's a scenario. A user uploads an image, an S3 event triggers a Lambda function that resizes that image, and that resized image lands in another S3 bucket. As we stated earlier, simple on paper, but a nightmare to debug in AWS. Let's go through a demo. Okay, so here I am uploading a test image to the sample apps UI. And behind the scenes, LocalStack already set up the infra, including the S3 buckets, the Lambda, and the event trigger that connects the two. And just like that, the upload triggers the Lambda, resizes the image, and saves it into a new bucket. So we'll see here, it is in the new bucket. No deploys, no staging, no coins. All right, tactic 2 is one of my favorites. Breaking things on purpose. Now, LocalStack does have a chaos engineering feature that injects failure automatically, but for the sake of this demo and using features that are available in the community version, we're going to break things manually. Let's say you think your workflow is wired up, but for some reason, the Lambda never the Lambda never files. Is it S3? Is it IAM? Is it the event config? Here's how we simulate that exact issue. The command I'm going to run next removes the bucket notification, meaning S3 uploads will no longer trigger the Lambda. So now we're going to upload the image again. And once we upload that image, we will check what happens in the UI. All right, so it says it was successful, but we already know we introduced an error. You notice that it looks like it uploaded, but there's a little funky thing going on in the preview window. But let's see what's going on in the LocalStack UI. After I refresh the UI for my last run, we notice that both images are in the original images S3 bucket, but now let's check the resize images S3 bucket. After a quick refresh, we realized that only one of our images resized. So our workflow failed. Notice we didn't get an error. So what will we do in the real world in this situation? Well, we chase the logs, maybe for hours. That brings us to tactic 3. Fix and verify quickly. In the real world, like we talked about, this mistake can cost you a whole deploy cycle. But when you're testing locally, it's just seconds. So let's redeploy the config with the bucket notification. Okay, so that redeploys the Lambda, reattaches the S3 trigger, and gets everything back in sync. And once everything is set up, we also have to, since we redeploy, we also have to set our URLs again. So let's go forth and do that. And once that's done, we will upload our next image. All right. And just like that, our resized image is back. Crisis averted. Let's make sure that we check in the S3 bucket to see whether our image is resized. Yep, we've got the second image. There we go. Okay, so Tactic 4 is all about automation. Debugging locally is great, but testing locally is where things really level up. All right, let me show you a test file for this project that covers both the happy path and the failure case. The Pi test fixture will run before the Lambda function to make sure that the Lambda function is active. So that means we don't have any flaky tests. In this first test here, we upload a real image to the bucket. The Lambda function is triggered locally via an S3 event. The test waits for the resize image to appear in the resize bucket. It downloads the image and it asserts that the file is smaller than the original file. And then it cleans up the uploaded files from both buckets. And what does this prove? It proves that your upload, event, Lambda, and output chain works. The resized image is actually different from the original, which will be smaller in this case. And all this happens without touching AWS, by the way. All right, then comes the second test. This one uploads a non-image file to simulate a failure. The app is wired to publish a failure notification to SNS, which is routed to SES. And the test pulls LocalStack's internal SES endpoint to confirm that an email was sent. It verifies that email body contains a file name that failed. And so why this matters is we're not just testing success. We're testing what happens when things go wrong. And we're verifying that our observability and failure paths are actually what we expect them to be. We're doing all this local. Okay, so let's go ahead and run this test. Oh, as a bonus, these tests are runnable in any CI pipeline. And this is how you move from hopeful deploys to confident shipping. You're not just building cloud apps. You're making sure that they're solid before you deploy. Look, our test passed. Okay, so mission accomplished. We got through all our tactics, and we've successfully deployed a cloud app locally and run through an automated test. Well, 2 automated tests, actually. So let me tell you about cloud dev I talked to recently. They were building a media processing pipeline, S3 uploads, Lambda, and a bunch of fan-out events with SNS and SQS, similar to what we just walked through. Totally normal stuff until it wasn't. They kept running into weird issues in their staging environment. Things like events not triggering, policy silently failing, and just a total mess. So they decided to rebuild their stack locally in LocalStack just to test things in isolation. Turns out one of their policies on their S3 bucket was scoped incorrectly and silently blocked event notifications from firing. They caught it locally, fixed it, and avoided pushing a broken config to production. No blown budgets, no angry customers, and just a local environment that told the truth. And that, people, is what success looks like. Not perfect code, but fast, safe feedback and the confidence to ship. This approach doesn't just save time, it also builds confidence. You catch bugs earlier, you reduce dependence on shared environments, and you ship higher quality software. So today, you've seen what AWS development looks like and how it doesn't have to be slow or expensive. You can simulate real event-driven workflows locally, recreate edge cases, and fix bugs quickly, all while keeping your cloud bill at 0. Before you leave this briefing, here are some best practices. Keep your local environment aligned with your IAC templates like CDK or Terraform. Use the LocalStack web UI to inspect your resources. I can't stress this enough, guys. Like, the LocalStack web UI is your friend. Reset your environments regularly for clean tests. And if you want to try this yourself, you can scan this QR code, or also there will be some resources available after the presentation. And this will take you to the sample repo and some docs. So your mission is no longer impossible, and now you have the tools to prove it. I'm gonna open it up for questions. I'm not sure if there are any, but while you all are thinking about all the questions that you have, I usually get this one. Can you use this in CI? As I mentioned briefly earlier, yes, you can. That's a short answer. The long answer is LocalStack works beautifully in CI because it runs headlessly and doesn't require a connection to real AWS. So you can spin up your stack using the same scripts that you saw earlier and then run your test suite against it, just like we did with PyTest. And if you're using GitHub Actions, there's even an official LocalStack action that handles everything for you, from spinning up the container to injecting credentials. It makes testing in the cloud, testing cloud infrastructure in CI just as easy as testing it on your local application. So instead of crossing your fingers and deploying to staging, you get fast feedback on infrastructure behavior on every PR or whenever you run your CI.